out of that. So in a sense, we have these different types of scopes, and we have different purposes for scopes. And the question we're going to ask ourselves now is, what types of scopes are there? Now, in general, the scopes are divided into two groups. We have dynamic scopes and static scopes. And what are they? I will explain with a picture. Let us suppose, for example, that a program, a piece of code, will be drawn as a square. All right, we have this square, this rectangle actually. And this is a scope. Let's call this, for example, scope main. And within scope main, we have, let's say, two scopes. Let's call this scope X and scope Y. Okay? Now, within scope X, we have another scope, and let's call this one scope Z. Now, let us assume for a second that the function order, the order of function calling was main called Y, which called X, which called A. Okay, that's legal. Another possible function calling that could happen was main calling X, which calls Y, which calls A, which calls Y. That's also a legal order of the function calling. They're both legal, and they both can be done. Now, in order to augment our discussion, let us add some variables. Suppose in main we have the variables A and B. Suppose within X we have the variables, let's say, A and D. And suppose within Y we have the variable D. Let's see if this works. Now, inside Z, we have a command that says cout. Let's see, cout, let's say A plus, let's add here something. Let's add here a B. Let's add here a B. A plus B. And the question which we want to ask ourselves, since we said that scopes, in a sense, define the meaning of the variables, or in a sense, which variable we're talking about. So which variable are we talking about? So there's two possible options. One option is that the A we're talking about is the A of X, let's call it A of X, and the B we're talking about is the main B. I think everybody would agree that this is a valid option. Notice that Z does not have neither A nor B, and therefore it's looking at outer scope and it finds A of X, but it still does not find B. And then we go further out and we find B of main, so we have A and B. That could be a valid interpretation. Now, if we look, for example, at this interpretation, at this order of function calling, so I can think of another interpretation. I can think of X, of A being A of X, but I can think of B as being B of Y. B of Y. Now, can you see why this can be true? So the two options can come out of this line of code, this order of function calling. But as far as the second order of function calling, which is also legal, there's really only one option. Now, where do these options come from? So the first one will come out if we have a language that does what's called static scoping. While the second option will come out if we have a language that does what's called as dynamic scoping. And what is the real difference between them? How does it really work? So the statically scoped languages, what they actually do, and this is most languages you probably know. I mean, most of the common languages that we deal with are statically scoped. So what actually happens is that the compiler, as usual, the word static means compile time. The word dynamic means runtime. So if I talk about static scoping, what I'm actually saying is that the compiler has to decide which variable we're actually talking about. Okay. Now, the compiler does not see this runtime calling thing. This happens during runtime, right? It has really no idea when it compiles this piece of code right here, the cout, right? How I arrived at that location. I could have arrived in one of two ways. I actually have them on the board right now. I could have arrived by going from main to y to x to a. I could have arrived by going from main to x to a to y. So notice the y here is meaningless because we're actually talking about a piece of code inside function z. So I actually omit this right here. And these two are equivalent as far as the compiler is concerned. When the compiler compiles this piece of code, cout a plus b, it does not know if you arrived at that location via the first function ordering or the second function ordering. Okay, so it has to decide based on some rule which variable we're talking about. Now, static scoping, since the compiler does not know how we actually arrived at this line of code, it's going to assume that the function order calling is inconsequential. Meaning to say that it couldn't care less if y was there or not. So how would that happen? Very simple. It looks at an outer scope. It says, okay, so we have z, and outside of z, we have x, and I found a. Great. Now I'm going to look at the static scoping. Keep looking. I'm looking statically at the static picture. And the next thing to examine is the main. And there is B, right? So it's looking at the static picture. And when it's looking for the parent of the current scope, when it's looking at the parent of the current scope, it's looking at the static parent of the current scope. So the static parent of the current scope is X. And the static parent of X is main. And therefore it chooses this method right here. It says X of A and A of X and B of main. But there are languages like Lisp and others that decide to use a different method of how to determine who the parent scope is. And they use what's called as dynamic scoping. So dynamic scoping is something that's determined at runtime. During runtime, I know the call stack, meaning I already know who called who. So if I look at the first calling order that we have here, so the parent of scope A is X. And the parent of scope X is Y. And the parent of scope Y is main. Now, if we look at the bottom row, at the bottom order of functions, so the parent of scope A is X, and the parent of scope X is main. Notice Y is not there. But notice there's a different parent ordering. It's a dynamic decision. Now, when I look at the dynamic scoping, I say, okay, so if I cannot find A in scope, it should be called scope Z. It's a mistake. It should be in scope Z in both places. It's the variable A, it's the scope Z. Right? So if I cannot find in scope Z the variable A, I search the scope's parent. Well, the scope's parent is X, and I found X. I found A, and therefore we have A of X. And if I don't find the scope, the variable B, I search for X's parent, and that's Y. And therefore we have B of Y. So we have over here two different ways of determining the hierarchy of the scopes. Are we talking about a static hierarchy, or are we talking about a dynamic hierarchy? And there's a very big difference. Now, most languages obviously deal with static scoping and not dynamic scoping, but you have to know that it exists, and there are languages that actually do that. Okay, so we have a distinction between static scoping and dynamic scoping. Most languages out there are actually statically scoped and not dynamically scoped. And we will talk about the advantages and disadvantages of every one of these after we describe more in further detail all how it works and all the mechanics. Now, there's one more thing I need to add already right now, that if there's no possible way in your language to put a scope within another scope, then the discussion is futile. There's nothing to talk about. So if our language does not allow us to nest scopes, then this is all meaningless. So we're obviously only talking about languages which allow for nested scopes. And all other language, and only then you can start talking about whether we have a static scoping or a dynamic scoping. Languages that do not allow for nested scopes, then does not exist.